Okay, introduction to the normal distributions and standard normal curve. We have already looked at this curve before. When you're talking about normal distributions, the mean, median, and mode are equal. You have a bell-shaped symmetrical curve, such as this guy. The total under the curve, the total area under the normal curve is 1. And that's a big thing to know. It relates to probabilities. Okay? The total area under the curve is 1. It approaches but never touches the x-axis. So the x-axis is a asymptote. You want to think of it that way? So it gets closer and closer, but never actually touches. You still have areas under there. They're just so small we don't calculate them. Notice the inflection points where the curve is concave down and then it starts curving concave up right here. That's always at 1 standard deviation away from the mean. Okay? So if you can find your inflection points, estimate where they are, you can estimate what the standard deviation is. All right. We're going to get into actual probabilities instead of just using that empirical rule now, today. All right, so means and standard deviations. The normal distribution will have a mean of anything, and it has to be a positive standard deviation. Deviations, remember, we got to have positives. So the mean gives the location of the line of symmetry. So wherever this is symmetrical is your mean, and the standard deviation describes how spread out it is. So you can see this mean is where? 3.4 or 3.5, okay? So this standard deviation is at -2, and the mean is at 3.5. So how many standard deviations? What is one standard deviation worth? 1.5. So you can find the mean and you can find the standard deviation just by looking where the inflection points are. So this mean is also at 3.5. You're just estimating approximately. Is it a whole 1 unit or a little bit less? A little bit less than 1 unit. So your mean is 3.5. Let's say your standard deviation is, I don't know, let's say 0.7. You're estimating. Okay? What's the mean in the third one? 1.5. And the standard deviation? Well, yeah, about 1, I would say. So your mean is your line of symmetry, and your standard deviation is how far it is to an inflection point, one of the inflection points. Okay? All right. Let's compare. Which one has a greater mean? Which one, or give me, let me rephrase that since there's more than one here. Is the blue graph's mean greater than the red graph's mean? No, they have the same mean, right? Is the blue graph's mean greater than the green graph's mean? Yes, okay? So you can see the means are different. Which graph, what color, has a greater standard deviation? The yellow, right? It's more spread out than the red and then the blue. So red has a greater one than the blue and so on. Does that make sense? Okay. So if a scale test scores from the New York State Grade 4 Common Core math test are normally distributed, the normal curve shown below represents this distribution. What is the mean? Estimate the standard deviation. So your mean, could you add the two ends and divide by 2? You could. So the mean here is about 305. I mean, that's what I'm going to do. 180 plus 430, it's symmetrical, is 610. If I take 610 and divide it by 2, I'm at 305. So that's your mean. That's where the graph's going to fold in half. could you also just look at the 305 to 430? How big of a span is that? 305 to 430. About 135. How many standard deviations are here? How many standard deviations do we have from the mean to this number out here? About 3, right? Because it's plus 1, plus 2, plus 3. Minus 1, minus 2, minus 3. So if I divide this by 3, approximately, what is my standard deviation? We are just approximating 25%. Oh, everything. Okay, do you understand where I'm getting that? All right. So it's about 40, 41, but I would say it's approximately 40 for the standard deviation, because you're estimating where that end is. You're just estimating. So there's got to be 3 standard deviations from the mean to this end, kind of where it's almost touching. All right, so that's the way you can approximate. All right. You can also look for the inflection points. It's hard to see the inflection point, though. It's about, there. But, it's where it starts, it's very hard to estimate there. All right, here we go. There it is. 68, 95, 99.7. That's empirical rule. The mean, if you put it in a Z standard normal distribution. So that means we're going to take these numbers of raw data and scale them so that they're all in the standard normal curve. Your mean is always 0. Okay, remember the z-score formula we used? X minus the mean divided by the standard deviation. That converts it to a z-score. The z number is telling you how many standard deviations from the mean your score is, above or below. Okay? So we're going to be very specific in finding our probabilities now. Instead of using the 68, 95, 99.7, we're going to use that big chart that I gave you, because we're going to be kind of in the middle here. All right? But you have to be able to use the Z formula. And really, the Z-score formula, we're going to talk more probably tomorrow with it. Okay? But we're going to figure out how to use that chart. It's a pretty easy chart after you get used to it. All right? So, on that chart, notice, it gives you a curve like this. On the back where it says negative numbers, you see the curve does this and it shades on this side. It's giving you the area to the left of your z-score. And on the right side, it has a positive z-score. It's still shading the area to the left of it. So that's important. The chart gives you the area to the left. So if I want to figure out the area, the cumulative area to the left of z-score 1.15, so flip it to the positive side. You want to go down till you see 1.1, and then you're going to go over until you're under 0.05. That is the area, the 0.8749 is the area left of that number. Okay? So you try negative 0.24. What is the area that corresponds to the area left of negative 0.24? So you need to be at 0.24, negative. You get 0.4052. Is that where you're at? You know how to get to the chart. Okay. So let's look at one. Find the area under the standard normal curve for z being less than negative 0.99. So picture what it looks like if z is less than. Does that mean left of? This is 0. Negative 0.99 is almost 1 standard deviation below, and less than. So you just go into the chart. What is it? Negative 0.99. What's the area? Nate?
0.1621.
I'm sorry, 16 what?
1.
1. Is that what everyone got? That's it. You're finding the area. That chart's giving you the area from that number to the left. And less than means to the left. Okay? Let's try another one. Greater than. So again, this is where 0 is. 1.06 is right here. And we want the area here. Your chart is giving you, the chart's giving you the green. What is the green area from the chart? What is the green area? That's 1.06 from the chart. 0.8554. How can I get the yellow area then? I don't want the green area. It's 1 minus. The whole thing is worth 1. So if I take 1 minus the green area, I'm going to be left with the yellow area. Does that make sense? So if they're asking for greater than, you've got to do 1 minus the chart. The chart's giving you the area less than. So if they want the complement to that, it's 1 minus. These are probabilities. Okay? The area under the curve is the same thing as a probability. So if they want the complement, you have to do 1 minus. Okay. If they want two numbers between, so let's see if we can figure this out. So I've got 1.25 over here and negative 1.5 over here. And does it matter that they're perfect? No. We want this area. $1.25 on the chart gives us this area. Negative 1.5 on the chart gives us this area. What would I have to do with those numbers to get the green area? Subtract them, right? So you would find 1.25 positive on that chart, and then find negative 1.5. Is it 0.606? It's still a pretty big area, right? So negative 1.5. Oh, it's 0.0559. Right?
I thought 0.06.
It should be just negative 1.5, which is the first number.
Yeah.
Oh, the chart. Oh, why do they do that? The back is flipped from the front. I've never had the negative part. The chart that I've always used is always positive, so you just have to figure out the negatives. All right. So we have to go all the way to the front. Okay. 0.0668. That's confusing. Is that good? Okay. So on the back, it's from weird. All right. You understand how to read the chart? You understand what you have to do with the numbers? And that's it for today.
Yes.